Hello, I'm Ben Law and I'm going to take you through a stage-by-stage roundwood timber frame build of this, the Woodland Classroom at the Sustainability Centre in Hampshire. Roundwood timber framing all begun when we built the Woodland House about 9 years ago, and since then gone on to build a number of different roundwood timber frame buildings. I hope this DVD will show you the techniques we're using, how we've evolved different joints that work in particular with roundwood, and give you the opportunity to have a go yourself and create and build beautiful structures using roundwood timber. I see these building techniques having a wide range of applications, from domestic houses, community buildings, industrial buildings, agricultural and forestry structures. The opportunities are great by using roundwood. Why we use roundwood is that roundwood is stronger, it's faster growing to use as a building material than a traditional sawn timber frame building. Go up a little bit more. At the basic end, I'm a forester, a woodsman, and I want to work with timber, and I want to see timber used and forests well managed and people involved with that. And it's that desire to see timber taken from its basic form through to a high value-added product, or in this case a community classroom, that inspires me to want to make new markets for this timber. Larch is a great timber for roundwood framing as it's got really good construction strength in both bending and compression, and you can use quite small diameter timbers to build a strong structure such as this. A well-managed coppice woodland produces an abundance of poles, and this is a great resource for roundwood timber framing. There's a direct link between good forest management and the materials we need for roundwood timber frames. We can manage our forests well, grow suitable species of timber, use hand tools and create buildings that will be long-lasting and aesthetically pleasing for the future. So sweet chestnut frame, straw bale walls with lime plaster, chestnut lath internal walls with earth plaster. Insulation in the floor and the ceiling is warm cell, which is recycled newspaper. And it's still very much the inspiration from which we build our other buildings now. It's the first roundwood timber frame, and the one that I look at because it's been here the longest, so it gives us ideas of how well things are working. And overall, it's been very low maintenance and a good family home. Building a structure, a home, a place, a shelter is kind of as intrinsically within us as maybe it is for any other animal that goes out and builds a nest or a home. And I think modern day building has kind of removed that from us and created an industry which is pretty heavy on waste, pretty heavy on the fossil fuel economy to create structures that maybe are not particularly, in a lot of cases, the structures we might want to live in. This way of building not only brings back the skills and the knowledge back to people to build their own structures the way they want, but it also empowers them and tools them up to feel like they really are creating something for their own future from their local materials. And I think if roundwood timber framing can get that message across, then that's a great step forward. We've got 4 people working here who have never worked with roundwood before. One in particular has never worked with wood before, and yet working with a few people with experience, we've been able to pull this together. there's a huge opportunity for people to learn, feel empowered about being able to go out into the forest, find the timber they need, build the buildings they need, and that kind of takes away a bit of the mystique that sits around building.
I guess the ultimate goal for a lot of us here is to build that dream home one day, and that probably rings true with everyone here, I should think. So, you know, if that dream could be realised, then I think, yeah, I'd be very happy.
Here and for here.
For Roundwood timber framing, when we lay out the foundations, we're not dissimilar to a lot of other buildings, especially if we're working with a building that is in its basic form square or rectangular. Once we start to deviate from that, obviously our foundations have to move away from the traditional use of right angles to find the exact corners of the building. So for a usual layout, we'll lay out string lines and use a 3-4-5 triangle to create right-angled string lines running across all four sides of the building. Even when the building is curving, we'll still start with that as our form, because if we've got an internal rectangle or square, we can measure back out from it to other points when we're laying out for the foundations. Each padstone has a number and a letter on it, and the letters represent the frames we're making on the framing bed. So you'll have row A, row B, row C, row D, and each of those will correspond to the particular frame we're working on. So for example, frame C might have 5 padstones running along the parallel length of it. So the laying out is quite critical to be sure that everything we build on the framing bed comes up in the right place. However, in this type of building there's always a slight degree of fluctuation, and therefore we build our pits that we compact the stone in slightly larger than we need to. So if we do need to adjust the padstone by a few millimetres, we have that flexibility to do it. Now, on this particular site, we basically have an alkaline soil. It's chalk based, and although we could compact the chalk in order to get better results from the engineer and satisfy building control, we've gone for a limestone scalping, which we've compacted. So we've got a cubic metre of limestone scalpings compacted here. We use a jumping jack compactor and really whack this down, so you've got this firm pit of stone. Then on top of that we put a York stone slab, or a natural stone slab which has similar strength to York. This is actually a sawn slab. It's a second-hand sawn slab. Sometimes we use more riven slabs, which are a little more uneven but still quite possible to work with. So we need to make sure that we've got a level slab. Once we're happy that that slab is level in all directions, then this is where we'll take our measurement from, and this is where the foot of each particular pole coming down from the building will sit. Can you see that? Can you see the cross wires? There's like a cross, very fine cross when you're looking through the viewer, and that's where you're looking at where that lines up on the staff, yeah? So that's how we take a measurement. So that gives us a datum point, and then we'll move on to the next stone and take another measurement and work out the difference between the two. And what is actually going to be important is the difference between the datum point and the other ones. This is Lodsworth Larder Community Village Shop, and again it's a roundwood frame using sweet chestnut, coppice sweet chestnut from Lodsworth itself. The poles are quite large in this. The crux are a big diameter, and that's because it's an industrial building, so it has to meet higher specification for building regulations. We also have just had a winter where it had 12 inches of snow sitting on the roof, and so it's been tested with a lot of extra weight on top, probably as much as we're likely to see in any particular winter here. In most of the Roundwood buildings we tend to have what I call indoor-outdoor spaces, verandas, decks, and these are my favourite spaces in the buildings, and gives it a real different feel to just a building where you walk straight up and in the door. Gives it this sort of extra element of being partially outside, partially inside.
This area was where we cut the timber for Lodsworth Larder, a mixture of sweet chestnut, thinning out the oak standards, hazel, coppice ash, and so this is now in its second year of regrowth. We've had an electric deer fence around it to keep the deer out, and it's now coming back well with good length of regrowth. One other thing that happened with this woodland, having not been cut for 50 years, is in the first summer after it was cut, we had a whole flush of violet helleborine orchids, quite a rare orchid that obviously had been sitting there waiting for the light to come in and came up in abundance during the summer.
A key component in Roundwood timber framing is the framing bed, and this consists of 6x2 sawn timbers that are made up to create a level platform upon which we lay out the frames. The layout of the framing bed actually marks exactly where certain components of the frame are going to be. So the top edge of this pair of 6x2s here marks the line of where this tie beam fits in. What that allows us to do is to make up one frame, place another frame on the same bed and line up the tie beams in exactly the same position. So this is the tie beam here, and this is running in line with this edge. So I know exactly where my floor height is, where my tie beam height is, and when we move up to the top end, we have posts to mark where the ridge pole is going to go. So really the framing bed is a map of how the building is going to look on the horizontal. So by making it on a level horizontal bed, when we raise it up, it will come up vertical.
It's got to come this way, way too much.
Working with Roundwood and taking techniques which have been there for years in traditional sort of green oak framing, techniques that are used out in Canada, America and Scandinavia for log building, bringing those together to form structures such as this, which I feel are quite aesthetically beautiful structures, but yet use the raw material of the forest. This gives the whole emphasis back onto what we're growing and how we're managing our land. This is sweet chestnut coppice. And coppicing is the process whereby we cut down a broadleaf tree during the winter months when it's dormant and the sap has gone back towards the roots. And when spring comes, it reshoots, and over a number of years it grows these poles. And these poles are then harvested when we need them for various uses, from craft work through to building work. And the process of coppicing can go on continuously for hundreds of years. In the UK, we're really fortunate that we've got more coppice woodlands than probably anywhere else in the world. It's a real resource that we need to keep using. A lot of it is being unmanaged, and really we should be getting all of this coppice woodland back onto cycle and using this renewable resource. We've got to stop designing buildings which are beautiful things in our imagination, but then we search all around the globe to find the materials. Where we need to start is, what materials have we got available locally? Let's go into the forest, meet the local woodsman. The local woodsman will be able to say, yes, we've got 20 larch trees, we've got half an acre of sweet chestnut, half an acre of hazel, that's all ready to cut, and then design the houses and the buildings from that. That way we're managing our local resource and also being able to produce buildings locally made out of those materials. And it's that connection that really inspires me to do more of this work. The joints we use in Roundwood timber framing, some of them come from traditional green oak type sort of timber frames, others come from log building, and some of them are unique to Roundwood timber framing itself. What I have here is a scribing tool which is used in log building, and what this does is it transfers the profile of one piece of timber on another. By doing that, one can get a very nice snug fit as the two pieces of timber come together. You'll be able to see on these joints here that we've transferred the profile of one log onto another and then cut out that shape. What it might look like is that this is just one piece of log lapped onto the other, but actually the joint is far more detailed than that. Within each of these joints there is a dovetail cog which is notched in from one log to the other. What that does is checks that there's no movement of the logs, but also ensures that when the frame becomes vertical, the downward force is not on the joint, it's actually transferred into the timber itself. And this is what makes these buildings structurally sound. Okay, this is the joint at the top of the cruck where they cross over, and Rudy's just doing a bit of hand scribing just to get it to seat down the final amount. The scribe done with the scribing tool has given quite a nice fit. The profiles are all nicely snug all the way around. It's just got to come down a tiny bit more, so he's just scribing this edge to take a little bit off here, which will just lower it down, and we'll get a really tight, snug fit between the two. It's looking good. You'll notice that in these buildings there's a lot of ratchet straps down onto the framing bed, but also for when we actually come to raise, we keep the ratchet straps on. The reason for that is the joints we're cutting are designed for the building when it's in an upright position. During the raise process, the building gets lifted from a horizontal to a vertical position, and then the joints go through a lot of tension. So putting the ratchet straps on and leaving them on during the raise supports the joints during that process. We've also got timber dogs here. Timber dogs are another tool used for securing the pieces of timber together. The ends of them are shaped at different angles, so that they work with the grain on two pieces of wood that are lying across one another. Very quick and easy for securing a piece of roundwood onto another. Lawson cypress that we've got here is not commonly used as a building material in the UK, but in America, where it's known as Port Orford cypress, it's been used for many years in construction purposes. It's also used in Japan in some of the temple buildings. The wonderful thing about it is it has its own natural durability. So we're talking about a wood that doesn't need any chemical treatments, and we can use it in its raw form, felled and jointed and then put up straight into a frame. And here we are amidst a plantation of Lawson cypress and beech. The Lawson cypress would have been planted as a nurse crop for the beech. Couple of rows of it which would grow fast and encourage the beech to grow up nice and straight. What's actually happened is it's never been managed, and the beech has been quite badly attacked by squirrels, and the Lawson cypress has grown on into very tall, thin poles, not of much use in commercial forestry. However, in roundwood framing, these are ideal poles. The reason for that is they're slow grown and small diameter, and a slow-grown pole will have the growth rings much closer together, and with a softwood like this Lawson cypress, that's just what we're looking for. So this is a plantation of potential roundwood buildings. This we're making here is an underfloor support beam, and Jacob is just fitting a staddle into it. We call these legs staddles, mainly coming from traditional granaries in timber framing, where a stone was supported, a bit like a stone, looks like a stone mushroom, and the timber frame would sit on top. We use wooden staddles to support the floor of the building where it's not attached to the main frame. We start with a round log, and we run these string lines along to make sure that where we're creating flats on the log, they're all in parallel and all in the same plane. Then mortises are cut out, and a staddle with a tenon on top is inserted in there. This will eventually also be pegged through, the whole beam turned upside down, and the floor joists, and then the flooring will sit on top of that.
So this is a staddle post arriving. The guys are lifting it and fitting it onto the pad stone. First thing that we do when we put one of these in place is have a look how level it's going to sit on the stone. Quite often it's necessary to recut the bottom to get a nice flush fit. This one's actually looking pretty good. Once we're happy that that's level on there, then we'll look at marking out where the tenon is going to go on top, and that will be the next stage, working out the shoulder and the tenon, and also the height difference from the pad stone up to the shoulder is what we did with the level measurements and calculations earlier on in the build. With this particular staddle, the cut on the bottom isn't level, so when we put it on the pad stone there's quite a lot of movement. So hence we've put a few wedges in just to bring it up into the vertical, and we've looked at that by eye down both planes, and we're happy with the plane that's in now. So the next stage is to then get a flat piece of wood, and we'll use that to actually scribe around the profile of the pad stone it's going onto, and then we'll recut the base. And once the base is recut and it sits nicely on the pad stone, we can then measure up to the shoulder for the tenon. This is a simple roundwood timber frame and shows the basic components that we use in many frames. So you've got your main crack poles riding up to the ridge pole in the centre, the jowl post coming up, tie beams running across. This particular frame has got what we call an interrupted tie, in other words it's cut in the middle here, and then we have an underfloor tie running along the base which supports the floor joists and the floor, and the wind bracing is what the guys are just working on at the moment. So this is what I call your sort of simple DIY roundwood frame, quite easy to construct, something that small amount of poles and a few people could put together quite quickly to create an attractive and useful building. Okay, just setting up to measure out where the cuts are going to be for the feet at the bottom of the frame. Taking a measurement off the framing bed where I know the floor height is, and measuring back down. This all corresponds to the measurements we took with the level off the pad stones. Using a laser level because it clearly marks the curve on the timber and gives us a much more accurate line from which to follow with the saw. Each foot, each cut will be at a different distance from the floorboard height down to the pad stone, and those are the measurements we have. So each one has to be individually measured, get the exact angle for the cut. The laser line gives us a clear line which we can then scribe around with a pencil, and then we'll actually cut to that angle, and all being well, when it gets raised up on the framing bed it should come up nice and level with the feet sitting flat on the pad stone. Most timber frame buildings are traditionally held together with wooden pegs, and in roundwood timber framing that's no different. So what we're doing here is making some pegs for the building. We're using oak. This is oak that I actually cut over a year ago, and I've been allowing to dry. The reason for that is we want the pegs to be more seasoned than the frame, so as the frame dries out it will shrink tight onto the pegs, and therefore holding the building together that much better. Traditional sort of green oak frames use a process called draw pegging, where you have a tapered peg, and the tapered peg is hammered in between two holes which are offset, so as the peg goes through it draws the joint together. Now with roundwood timber framing that's not so easy, because we've got the third dimension of this extra curve in the timber.
So the process we use is creating a cylindrical peg, and we do that by first of all ripping down the oak into a square section, and then, as Mark's doing here, we start to work it on the shaving horse using a draw knife to take off the edges and work it down so it's then ready to go into something we call a rounding plane. And a rounding plane is basically a giant pencil sharpener. And what it does is, by working it down, this little spoke-shaped blade will turn this into a nice even cylinder. These planes come in different sizes. This one is 25mm, so I'll know the exact size of peg I'm getting, which will come out this end. So it's literally a process of just working the rounding plane down through the oak and getting a peg of the perfect cylindrical diameter we need for jointing the timber. These rounding planes we get from Asham Crafts, and Asham Crafts is run by a great character called Peter Hindle, and Peter's been supplying me these now for about 15 years. Peter worked with these quite early on with Fred Lambert, making traditional country chairs, which Peter still makes. And these, to us, are the real essential tool for peg making.
They were made originally as wood tools for making rungs on fruit picking ladders. We eventually developed them into a casting, and using a spoke shave blade works very efficiently. We used them to begin with by hand, by rotating them on a piece of wood to make a round dowel. Eventually then, the originator, Fred Lambert, decided he needed some mechanical means. Now, a lathe, wood-turning lathe, was far too fast. So what he did, he developed a little gearbox system where we could slow the speed down, right down to about 60 RPM. So we used a little gearbox out of a three-wheeler Reliant, and it had, of course, the 4 speeds, and in the bottom speed, with a 4-to-1 reduction with the pulleys, from an electric motor we got a speed of about 60 RPM. Put it into the 4th gear and you've got 400 RPM, which is all right for very, very thin dowels. So the thicker the wood, the smaller the speed, slower the speed you need in the gearbox.
Now obviously making pegs as we do is a lovely way to do it, each one individually by hand, but it is quite a slow process. And when we're on a big build we might be needing 300 to 400 pegs. So having some way of speeding up the process has always been something we've been looking at. And Peter has made this wonderful turning head for us, which is just a great piece of DIY engineering on his part. We've got this lovely Robin Reliant gearbox that he's pulled out of an old second-hand car and got that going to give me the speed of turning on this machine. He's also managed to find a second-hand 110 volt motor, so we can use it through a transformer, so it's actually reaches site safety for using on building sites. And it can really speed up the whole process of making pegs.
The kids used to like doing that at school, and then one boy, he got it caught up here in his trousers. You can imagine what the other kids thought to it.
For drilling out the holes, there's a range of different drills you can use. This is probably the most extreme, a 2-stroke petrol auger drill. Useful when you're working sort of away from any power supplies or when you've got a lot of holes to do. But you could also use a bar auger or Scott's eye auger and do it manually that way. And then high torque, low speed electric drills are also fine for doing this type of drilling. Once the hole is drilled out, we then knock in the peg. And that's quite a comfortable fit. In order to make sure that this peg can't slip and the joint can't open up, we then wedge the peg from each end. This is an oak wedge we made earlier. I'll need to put one in the bottom before I knock that one home. Once the frame is completed on the framing bed, we then move the frame over to its final position before it's going to be raised, so the feet are sitting on the pad stones. The frame is dismantled and brought over in pieces. Sometimes we move the main A-frame as one piece, sometimes we move all the poles individually and then reconstruct the whole frame in situ. One of my main interests with roundwood timber framing is seeing how these buildings are going to be useful in the future. I believe in 40 to 50 years' time we'll find it a lot more difficult to build buildings which involve bringing in materials from long distances and use a lot of high energy equipment to construct. Hence, one of the beauties of roundwood timber framing is that you can go out into your local forest, harvest the trees and build with them in the round. But we also need to look at species that are going to be available and suitable as temperatures start to warm up. A lot of the trees that we're familiar with now might not be so healthy or so useful in 40 to 50 years' time. So we need to look at ones that are going to adapt well to our climate. One such tree is the black locust, Robinia pseudoacacia. And this tree has many great properties for roundwood timber framing. To start with, it's a nitrogen fixing tree, so it's going to benefit other trees around it in the forest. And then there's the timber itself. In North America, where this tree grows a lot, they describe it as lasting a year longer than stone. So this is a really durable timber. We're looking at a timber as durable as oak at least, so has huge possibilities for building without the need for any treatments of the timber. It coppices, it suckers, and it's fast growing. Really is a tree I think we're going to see a lot more of in the future in our forests in the UK. When I stand here in amongst the frames at this stage in the build, you can still see the whole form of the trees, the whole shape of the roundwood that's been growing, and yet within this we've actually got some very strong jointing techniques. What I like about roundwood framing is, one, that you keep that form of the tree in its purity, but also you're able to use timbers such as these, which are quite small dimension as regards age of trees being growing. Most of the trees in here are about 30 years old. And when I look to the future, we're going to have to look at how we're going to be able to build buildings using trees that maybe we don't have the equipment to saw up down into sawn square edge timber. We're going to have to start thinking about tree species that are fast growing, that may be more adaptable to global warming, and this is where roundwood timber framing has a really key element to play, I think, in the future.
This is an area we coppiced this winter, and what I'm standing by is the regrowth of hazel coming back for the first time in about 40 years. This area contained a mixture of oak standards, which are the taller trees, over the top of ash coppice, hazel coppice and chestnut coppice. The ash we use for wind bracing in the buildings, the hazel for wattle and daub and woven panels, and the chestnut for the main frames. The oaks that are the standard trees here, we've also felled quite a few of those, and they'll get planked up and used for the cladding and the floorboards. So while I'm utilising that material to build with, the new growth of the coppice is coming back, creating more product for the future.
You can see on the bottom of the posts here, we've painted the bottom, and this is with a mixture of wood tar and citrus, and this just seals off the end grain of the timber. If you imagine with this, where the end grain of this timber hits this padstone, that's the most likely point for moisture to try and absorb and work its way back up into the pole. So this is just to give it extra protection. We also, once the frames are up, we use a couple of bottle jacks, and we'll actually put the bottle jacks under this floor support, and we'll lift the frame up a few mil, and we'll slide a bit of slate under, a bit of roofing slate, and then trim that round. So we'll have the protection of this wood tar plus the slate, which just lifts it a little bit up above the padstone. I'm not expecting to get moisture working its way onto the padstone, but if it does, we've made sure that these are lifted that much higher to make sure that it doesn't get any moisture sucked up through the end grain. When we raise these frames, there's a tendency for the frame to want to shift forwards on this padstone, and as we're pulling from the top, winching it up, these dig in, and often these padstones will try and slide. So that's why we put these 2 steel pins in each side, and they actually stop the padstone from sliding, and it helps to get these feet to bed down onto the stone and for the whole frame to raise up. We also have the tourniquet ropes tied back to the post at the back there, and these tourniquet ropes we can tighten with a peg, and they'll also restrict the frames from sliding this way.
Yeah. Go one more, that'd be good.
Come on.
Yes. Very good.
These temporary supports here, they have a V cut into them, and these we've put in to get the angle of the frame up a bit before we start the raise. The hardest bit is getting a frame from horizontal up to about 60 degrees. When it's at about 60 degrees, it starts to raise really easily. So by getting maybe 30 degrees of that lift done manually on a couple of small tripods and then getting a support underneath, it just improves the whole ease and flow of how we raise the frames. So these are in here temporarily. As the frame goes up, they will just drop away. And there's 4 ropes attached to each frame, and they form the front and back lines. So they're a bit like giant guy ropes, as if you were anchoring a tent. And one person will be on every rope, and they'll then secure these either to pegs driven in the ground, or posts driven in the ground rather, or else to trees to get a really good anchor point. And because once this first frame is up, and we've got these ropes on, the ropes will be the only thing supporting it until we get the next frame up, when we'll put temporary bracing in between them. We weren't blessed with the weather for the frame raising day. In fact, it's the wettest frame raising I've ever done. But however, it all went pretty smoothly considering that. Okay, good and steady, she's coming up. Poles are a bit slippery, and certainly if you've got more choice in your timetable to choose a better day, then I'd recommend that. The actual raising day it's quite a military operation. Everyone has key roles they have to play. We have to stay very focused right the way through the raise. Frame raising with these Roundwood frames has come a bit of a tradition with us. It feels very much part of the celebration of having put the work in, worked from the felled tree through to the finished frame, and it's kind of the celebratory moment to pull up these frames in a day. It's a very focused day, and by the end of it you see the fruits of the last few weeks' work come into being as the whole building is standing. You can really start to see the structure. But at this stage now, all the main frames are up and we're moving on to fixing the wall plates, tenons on top of the jowl posts, and I can kind of see the actual formation of the roof not that far away now.
The most difficult part so far probably was the frame raising, just because of the weather, but it all went smoothly. And seeing your sort of work go up, being raised on the day, and that's just what it's all about. That's the reason why you do it. Well, what I hope to do is sort of take the skills back to the area where I'm from and see how it goes, and sort of try and promote Roundwood timber framing as much as possible within the area that I am, because obviously the whole point of it is it's a localised business with only a certain working radius.
With many Roundwood buildings, we don't actually use any form of fixing to hold the building down. We use the natural weight of the building just to sit there comfortably on the padstones. But the nature of this building is that it's going to have quite a big roof, and it's going to be open at one end and two sides, so there's a big opportunity of the wind coming through and gathering under the roof at the far end of the building. So I want to make sure that it doesn't work at all as a sail and try and lift up. So the way we compensate that is to actually fire 4 earth anchors into the ground. Now these are a steel anchor that we hit in with a jackhammer, and we knock them in about 3 to 4 metres into the ground. The anchor has a stainless steel cable on the end, and there'll be a rigging screw in here, and then it will be looped round the cruck, and that will secure the frame down into the ground. And we'll do that in 4 positions on 2 of the separate frames. So we've got like 4 corners of the building all supported internally. The anchors, of course, will be disappeared into the ground, and all you'll actually see will be just the loop of cable and a rigging screw, and that will of course be underneath the building, under the floor. So it's not something that's visible, but it's an important part of making sure that this stays stable in high winds. One of the reasons we use earth anchors is because it avoids using any form of concrete to anchor the building down. Using just the natural weight of the subsoil, by being able to get the anchor deep into the ground below the subsoil, makes a very good fixing point and just uses the natural weight of the earth to hold the building in place. And we then tension up that cable, and as we tension it up, the anchor turns in the subsoil, and so you're actually pulling against the weight of all the subsoil on top of it. So it's not dissimilar to the process of a ship's anchor out at sea. Once we take up the tension on that and we can put a load of say 5 tons on it, we will then use a turnbuckle or rigging screw and put a loop around the cruck. This is the compost toilet at Prickly Nut Wood. It was built by myself and volunteers who've been staying here, and I think it has one of the best views of toilets in the country. The split chestnut lath that we've used here to make the panel walls is the same split lath that were used in the woodland house to make the earth plaster walls. And also on the gable end of Lodsworth Larder we used it to add the lime plaster to. So this is the basic ingredient made out of coppice wood for forming the walls in these buildings. Being split or riven, it has a rough finish, which is what makes it so good for getting a plaster to adhere to. I also just quite like the look of it in its raw form like this, as it lets in a nice dappled light into the interior. So this is the ridgepole. On this build it's made in 3 sections. There's the the main middle section, which is a straight ridge, and then we've put on these two curved sections to create the profile of the roof. The ridgepole on this building is quite unusual because we've got the main section, which is a straight ridge, and then we're dropping away with two curves to form the shape of the roof. And we've put a bridle joint in here. This is where you have one long tenon for a big deep open mortise, and then it's pegged through in two places. Some pegs here. This will be trimmed off, and this will form the actual curved shape of our roof. The other thing is these, what I call the horns of the crux. These will also end up being trimmed off all the way along the ridge, so they're at a uniform height, and the roof rafters can attach into the top of the ridgepole. As it works its way down between the crux, it's pegged into both crux and then dips away to form the final curve at the bottom of the roof. We'll then mirror this curved shape with the rafters, which we've been steam bending, to create a sort of curved, oval, almost sort of turtle shell roof over the top of the building. We're steam bending the roof rafters here. What that involves is boiling up a big amount of water to create steam. We run that steam through a laundry pipe. The process of steaming involves saturating the fibres of the wood with steam so that it becomes flexible. A bit like a piece of spaghetti when it's dry. You boil it in water and it suddenly becomes bendy. Once it dries out again, it becomes solid. The same with steam bending. You saturate the fibres with steam, bend the piece of wood over some form of jig that shapes it, clamp it in position, and then as it cools it sets in that position. This is a little experimental from the point of view that Lawson Cypress is not well known for its steam bending, but I don't know of people who have bent it in the round. Most steam bending is done for boat building or chair making, and it tends to be done with sawn or cleft pieces of wood. In the round, because the fibres are all intact within the piece of wood, there's a lot more possibility of bending it without the wood buckling or splitting out. And we're actually only going for a gentle bend just to create a nice curve in the roof shape. And so far it's going really well. The roof rafter is fitted into the gas pipe, and then we've packed it with clay around the outside. And we steam each one of these for about 3 hours of intensive steam. And then take them out of the pipe and take them over to our jig, where we sit upon the actual rafter to weigh it down and then ratchet it in position. And it will sit like that for 24 to 48 hours. And then we take it out of that jig and take it to a setting jig where it will sit for a couple of weeks, and then it'll be ready to go on the roof. You have to be careful working with steam under pressure. Steam engines have a huge amount of power, and if the steam gets pressurised, something will have to blow or pop. Hence, we've got light seals on the end of the steam box, and you can see steam is happily escaping out of there. That ensures there isn't a build-up of pressure, and therefore there's no chance of the actual steam box exploding or blowing, which would be possible if it was pressurised steam. This is one of the wall plates, and as you can see, we've steam bent this to create the curves we want to run along the side of the building. It's quite a large piece of timber to bend, so we've put this in the steamer jig for quite a few hours to get the degree of flexibility into it. And then we've actually used the existing frame we've now erected as a mould, as a former, to bend this around. So this whole beam has been bent round the jowl posts on the frame to create this effect, left there to settle for a few days before we brought it up here and popped it down on the tenons coming out of these jowl posts.
You can mark where your tenons are.
So this is on top of the jowl post, and this is a tenon coming up that's going to pick up the steam bent wall plate as it runs through. this tenon is set off at a slight angle. If we were putting in a straight wall plate, it would be more like that. But because we're allowing for the curve, which is going to sweep round through there, we've offset the tenon to that angle. Although sometimes you can find pieces of wood that have this type of curve, it's quite difficult to find the exact bend you want to fit a whole outside curve of a building. So steaming really comes into its own when you want to create these perfect shapes to form the outer curves of the building.
You have to somehow get in your head like the idea of curves and of round shapes and how to work with them. As if it's square, maybe it's a little bit more easy, but once you get to the stage where you can understand the curve and you can understand the circle, how it works and how to work with it, it's extremely interesting.
Trees that have grown with a curve or an bent like this are usually not wanted in commercial forestry, but they can actually be really useful if you're looking to create a building with curved wall plates. We spend quite a bit of time steam bending timbers to create shapes like this, but in a lot of cases you can find them naturally growing in the woodlands. For me, my approach with these is to actually design buildings around the shapes I'm finding. That also makes me look at the whole approach we have towards designing buildings, and in particular architecture in relation to buildings. A lot of architecture works around actually designing an image and an idea and then finding the resources for it at a later date. One of the things that foresters can do to link up with architecture is to actually invite architects to the forest and let them know what is available, rather than designing the house and searching for all the materials from all around the globe.
We're at the rear end of the building here, and the wall plate that runs around sweeps out into a curve here. But rather than following the same level all the way around, I've decided to drop the wall plate. So we've got kind of a swooping tail end to the end of the building here. And I think that's going to look really nice as the shingles come down over the top of it. We've also been laying out the first lot of rafters now. These are quite a few weeks of intensive steam bending to get this number ready. And it's really nice to see the shape of how the roof is going to form.
There's 5, is it? From that last one, we've got 1, 2, 3.
This is just an initial layout. Each of these will have to come down, be shaped, repositioned and jointed into the ridgepole and into the wall plate. They'll also need to be cut plumb at the top, so they sit flush on the ridgepole rather than side to side as they are at the moment.
Done a few of these with Ben now, and that looks like it's set to continue into the future, which is great. That's a great thing about doing this, really, is sort of gaining the skills and sort of honing the process, improving the techniques that we're using with each build. Knowing that one day I'll be able to, hopefully, be able to use all these things on building my own place. So.
The timbers on this particular stem are ideal size for roof rafters, wind braces, and could be used as they are in a building, even quite a large building, for wind bracing. If I allow them to grow on for another 10 to 15 years, they'll reach a size where I can use them for wall plates and crux, and whole buildings can be made out of them. A pole of, say, 6 or 7 inch diameter of sweet chestnut, which can be reached in about 20 to 25 years quite comfortably. It would take a pole of oak of a similar size would have about 1/10 of the amount of heartwood in it, which is why oak tends to be grown on much longer cycles, whereas sweet chestnut can be harvested anything from 4-year-old for use in roundwood battening through to sort of 40 to 45-year-old for large poles for timber framing. It's also a species that's likely to do better as our climate warms. It's a Mediterranean species and should spread happily further north across the UK.
We're in the process of fitting the wind braces at the moment. These wind braces or sway braces are what stop the A-frames or crux frames moving in one direction or the other. The actual structure of an A-frame is very, very strong. That form of the letter A is very solid in that direction, but it can move from one side to the other. So the main purpose of these braces is to stabilise the building and stop any racking of the building. It's quite a slow process. Each one needs a little bit of individual work once you come to actually fit it in place. And with the nature of these wall plates we've got on this building, because they're curving, the angles between the jowl posts and the wall plates are all slightly different, so everyone needs individually hand sculpting into place. They're then temporarily ratcheted up with these ratchet straps until we've got them all in place and we're totally happy with the positions and the angles of them, and then we'll drill through and peg. Each tenon will have 2 5/8 of an inch peg straight through there, so there'll be 4 pegs into each, and that will lock the whole building together. Once that's done, we can then take off all this temporary bracing and any ropes, and the building will be freestanding at that point. This is our wind brace mitre box. It's designed to be able to put a round pole, which we're going to use as a wind brace, into the box, and then cut the exact angle across here at 45 in order that the tenons coming out each end go in at 90 degrees to the jowl post and the wall plate. There's 2 parts to the box. There's the main box itself, which the wind brace is sitting in, and then there's the template, which we can then use to offer up between an upright jowl post and a wall plate. And this particular template, we sit this piece onto a flat we've made on the jowl post or wall plate, and then we can scribe around the inside to make the mortise for which this tenon will then fit into. For making mortises, the traditional method, and one that we teach to start with on any of our builds, is to work with hand chisels and mauls, and this involves using a corner chisel to cut the right angles and then dig out the mortise with a series of framing chisels. When you're doing a great deal of them, the commercial alternative is using what we call a chain mortiser, which is basically a chainsaw chain, although a lot thicker, which actually cuts out a great chunk out of the mortise in one go. These can be angled, orientated and moved quite easily once the mortiser is clamped or ratcheted on to the pole you're trying to cut the mortise out of. This is the Woodland House, the first prototype Roundwood timber frame building I got involved with. I've been living in it since, and it's really out of this all the ideas for Roundwood timber framing have evolved. This internal wall, which is an earth plaster from the pond in the woods, has got chestnut lath underneath, and you can see where the tannins from the chestnut have come through and affected the colour of the wall. It gives it a very medieval appearance. It also works as a passive solar wall in the winter. When the sun is lower and shines through onto it in the winter, this will absorb heat and then let it back out into the room in the evening when the sun has long disappeared. Straw bale walls combine really well with Roundwood timber frames. It's the ability to sculpture the curves into straw bale. Kind of gives the same feel that you get from the natural curves in the Roundwood. These bales are barley straw. They were put aside in a barn for a year to compress before being used in this building. And then they have 3 coats of lime on top. First a hurling coat, which kind of splatters the bale, and then a coat mixed in with horse and cow hair, and then a final
lime putty and sand coat on top. And this goes off into a very hard wall, but you really get the nice forms and shapes of the straw beneath. Obviously it has very high insulation qualities, and it also gives great depth to the walls, which makes it perfect for a window seat. This is typically 1 bale high from the floor to the bottom of the window seat, and it's just the right height for sitting and enjoying the view. The gable end of this building has a lime plastered wall as opposed to being timber clad. This forms a fire break from other buildings around it, and it also makes a nice contrast to the Roundwood, having the timber cladding coming down one side and then emerging into a round pole and then coming out the other side into a finished lime plaster. And these buildings need to breathe. They're all made of natural materials, insulation's designed to breathe, so any moisture can escape out of the building, work its way out through that lime. If this had been a cement wall, it would have trapped the moisture inside, and that causes problems to timber further down the line. We're having a week of clay this week, and we're starting to mix up an adobe mixture for the floor around the fireplace end of the building, and also to make the mortar for the cordwood walls we're building on this curve. So this is clay that has been dug out from where somebody was building a barn nearby. They needed to dig out into the side of the hill, and this clay came out. It looks fairly sandy when you look at it, but it's actually got a very high clay content, and the sand will help it all bind together when we actually mix it up. So we take the clay from here, and it goes onto these tarps. We add a fair bit of water and a bit of chopped straw. So Nick's puddling away with the clay mix here and just working it with his feet. And what that's doing is it's breaking down all the lumps of clay in here and mixing them thoroughly with the sand and the straw to get a really good consistency of an earth plaster here. So this type of daub mix becomes a very sticky, clay-based, mouldable plaster that you can either use on walls or between logs in a cordwood wall, or as a base for when we're building floors and we're putting in an adobe floor here as well as a cordwood wall. So this is absolutely ideal. What you want is to see that sticking to my hand. It's got a good clay content, and yet at the same time you can roll it and create a fairly malleable ball which you can then shape as you want between different parts of the walls. And once we've got this all finished and down to a nice texture, we'll then move it and put it into the floor where we've got shuttering set up, and the floor will be built up with a series of layers, and then we'll finish it off with some slip coats of very fine clay and water which we can smooth in, because as it dries it will be some natural cracking, and these slip coats will sort of smooth out all the final cracks. And once it's fully dry, we'll then seal the whole floor with a few coats of linseed oil. Should come up a lovely colour with this clay. I'm just pointing up the cordwood walls. These are made from western red cedar and Lawson, which has already been seasoned. Basically we cut the logs to 18 inches, that's the thickness of the wall, and then pack in a clay and sandy cob mix in between, mixed in with a bit of chopped straw to bind it. And I'm just filling in any cracks as it dries out. You have to put on a number of slip coats just to fill in these finer cracks that appear between the logs. The reason we use seasoned timber in it is because these will shrink, and if you were to use green logs they would shrink down and you'd get quite a gap at the top of the wall. Over time they will need a little bit more pointing and adding of clay, but once it's fully dried out it should need no more maintenance. The battening is fairly conventional, working at set distances apart up the roof. The only place we have to alter this is as we go around the corners or as the actual shape of the roof changes. As we work round over the top of this cordwood wall and the roof kind of kicks down into a sweeping tail, we're having to alter the battens quite considerably. One, to flex our way over the top of some of the curves, but also as we drop down, the battens lose their sort of symmetrical rows, and therefore we have to put in a lot of extra battens, cut them in, shape them, and as we're shingling we'll have to work them a bit more, chiselling bits out as we go. But the end result will be a sort of sweeping tail on the outside of the building here, which will not only protect the cordwood wall, but will give the building and the whole roof a real sort of sense of stability and depth. Here, coming to see Chris, who's making shingles for the woodland classroom at the Sustainability Centre. These are all handmade from western red cedar, locally sourced, and Chris has worked out his own methods of taking it from the butt through to the finished product, and he's making a fine lot of shingles for us.
I buy all the timber off of Cowdrey, which is the local estate. This is western red cedar. After they're cross-cut, they're put into these blocks. We clamp 3 at a time. I'm actually at the end of cutting the Sustainability Centre roof, and this is the last 5 blocks. When I actually start saw up in a minute, you'll see that it's a very simple technique. We just literally raise the block and that puts the taper onto the tile. And this will produce the shingle. That is the finished result. In there is 17,500 tiles, which is what the centre's requiring for the roof. I cut the tiles green. They'll go onto the roof relatively green, but they do, in essence, space themselves then. Now I've finished this, I can crack on with my house. So.
This is Chris and Lucy's Roundwood timber frame house. They're building a self-built house for their family, and it's coming along really well. Hello folks, how are you? Hiya.
Can't wait to get in there, really.
Yeah, wander on in and have a look. Great to see the house at this stage, where you can see the straw bale walls. Some of them have been clipped back, the others have got their first coat of plaster on, and different stages of it all coming towards fruition. It's getting closer to the end. One of the beauties of Roundwood frames is that because there's no fixed structure of where walls are coming up off foundations, you can be really flexible with the design in here. So once you get to this stage, if Chris and Lucy decide they want to move their kitchen over there, or they want to put a partition wall across, they can do it. There's no need to follow the exact footprint of the foundations. You can actually evolve the building quite a lot to how you want it when you get to this stage, and I think most people who are building their own house want that degree of flexibility.
I don't think there's a piece of timber here that's travelled more than 10 miles. It's look at it, it's beautiful. You have to think outside the box to build one of these houses. The nature of the structure itself, it's a round pole building. You do have to scribe and do various bits and pieces that you wouldn't have to do in a box. But when you see a round timber pole construction in a woodland situation, there is nothing else that you can put in an environment like this that just looks as though it's always been here. They're amazingly tactile buildings. They're made from local source timber. It ticks all the boxes.
This roof is quite different to a conventional roof for shingling, partly because we've steam bend the rafters. There's also a lot of curves that we've got to work round. So it's a little bit more challenging than most, but provided you follow the basic principles of shingling, which is to make sure at all times you've got a free shingle overlap. Every shingle that goes on must have at some point where that water runs off 2 other shingles underneath it. So we follow that pattern throughout. Now, because the roof curves, the shingles can't all be uniform and straight, so we're having to shave pieces off the shingles so they taper slightly as they come in and work their way up the roof towards the ridge. And as we get to the roof lights here, we're having to cut and shape all the way around them individually, all the shingles. They're going on pretty nicely all in all, and I think they're going to look very sort of reptilian, like scales, when they're finished across the whole roof of the building. Being Western red cedar, they're full of tannic acid and they need to be fixed with something that won't be corroded by the tannins in the timber. So we fix these with ring shank nails, which are silicon bronze. You can also use stainless steel for these, or copper would work. These won't be corroded by the timber and they work really well for holding down the shingles. One advantage with Western red is that you don't need to pre-drill them. When we're working with chestnut or oak shingles, you've got to pre-drill every time you fix one of these. One of the things I like about shingle roofs is being able to look up from the inside and actually see just the different layers of wood built up one upon another. And here with the skylights in the roof, we're going to get really nice features of light coming down, highlighting the roundwood frames.
I spent a lot of years in construction and watching the whole process going on around me and being involved in it, and you know, knowing it was really wrong, a lot of things that were going on and stuff, and people just going there for money. People actually want to do this, you know, people are quite prepared to come down here, give up their time, their holidays, you know, and help out. People can get together and do this, and it's a community thing, you know. Every build that we've done has involved so many people. They've just come in to help us out and stuff like that. And I think that's where it is. That's the glue for it all. It's the community thing.
One of the advantages of having a roundwood underfloor support is that the joist can be cut into the roundwood beam, so we flatten out an area and they actually sink into it, which gives them support, a bit like a small noggin. And then we will also run actual noggins as well between them, so it helps to make a really stable floor. And these beams here in the round are far stronger than a square timber that would be in there. That's probably the equivalent of an 8 or 9 inch square sawn beam. So it's got a lot of strength running through the building. So these joists will then be skew nailed to secure them to the beam, and then we'll finish off the top with some Western red cedar floorboards. And these will have to be left with a slight gap to allow for the changes in sort of humidity and moisture content they're going to have, due to the fact that the building is exposed to the weather, certainly on the outer decks, and also the fact that it's an open building with no walls. We will get at times rain blowing in and strong winds, so the floorboards have to have enough space to allow themselves to expand and contract, as the moisture will make the wood do that. Western red cedar is a great timber to use for that. One, because we've been able to source it locally, but also because it's naturally durable, full of tannins, and also a stable timber. In other words, once it's dried out and reached a certain moisture content, it won't expand and contract too much if it gets showers of rain, etc. on it.
I'd like to do this for a few years to come, you know, and then see where it leads, you know. Maybe be running jobs for Ben, or if Ben stops doing it, start doing it for myself, you know, or doing it with the rest of my colleagues. Because when I sort of first kind of qualified or trained as a carpenter, I think I was sort of thinking more in terms of this, and of course the reality is nothing like this. Roundwood timber framing it's a natural form. It's not about straight lines, so you're not looking for perfection. You're looking for the sort of randomness of the natural wood, and it's sort of naturally beautiful. You know, you take a beautiful form. It's like cooking or something. You use the best ingredients, and you know, almost the thing does itself.
constructing the fireplace, which is a central feature in the whole building. Because of the nature of the fact we've got the ridgepole coming right down the centre, we've had to sort of create this jaunty angle to take the chimney off to the side and out. What you're seeing here is the guts of it, really. None of this will be visible by the time we've finished. It will be a clayed, adobe-looking fireplace. I'll pull the string off when you come through. It's not a usual open fire. It's a very energy-efficient fireplace. It's designed by an American heating engineer by the name of Count Runford. He was around in the 1800s, and he visited the UK to look at the fireplaces we had here, in particular the old ingle nooks. And although he thought our fireplaces were very beautiful, he thought most of the heat went up the chimney. So he was the first person to really design an angled firebox, and also how the smoke chamber and flue system works on an open fire. And although this is an open fire, it works in a very similar way to a wood burner. It actually has a damper that you can shut down the chimney to slow down the draw of the fire. It has the angles to push more heat out into the room, and also being a clay fireplace, it holds heat in this clay after the fire has gone out, which then puts heat back into the room. So for an open fire, it's very efficient. He also came up with different designs for the throat and the smoke chamber on the fireplaces. So this is actually a precast clay throat under here, which is specifically shaped to draw better and make the fire burn more efficiently and cleaner. On an internal fireplace, you also fit a damper up in here. So you've got the option of shutting down the chimney and reducing the speed that it's drawing, hence making it more efficient and allowing more heat to come back into the room. With this fireplace, because it will have the clay surround, that will warm up as well and work as a bit of extra thermal mass, so that once the fire is out, there'll still be some warmth from the surrounding clay.
Ben Law is he's an inspirational figure in the woodland craft movement and in the permaculture movement and sustainable building, but also he's local to here. He's been known to us in the centre for many years. He's been involved here since we started, so we felt it was very fitting that he was the one that helped us to build this beautiful structure. We have buildings here, we inherited them from the Navy, and they do the job, but they're never going to win any prizes for architecture. And a lot of the skills we teach are about being in the outdoors, enjoying nature, learning about woodland skills, and we felt that we needed some kind of beautiful, inspirational space that people could use for learning, that felt like it was in the woods and gave people a connection with nature. We also run a natural burial site. We have about 850 people buried here at the moment, and we're doing about 4 or 5 funerals a week. We run a hostel and a campsite as well, so people can come and stay here, learn about sustainability and have a wonderful time in this beautiful part of the world.
So Nick and Andy are just fitting the last of the handrails onto these support posts coming up through the floor. The handrails have been steamed to mirror the profile of the wall plates of the building. They're then notched into the upright posts and drilled and fixed into place. We're right at the end of the build now, and trying to get the steps finished on the final day means everybody has to get involved. Basically, we've used some of the Lawson cypress poles and put them through the Wood-Miser mobile sawmill to create a flat face. Then, measuring the angle, we've created 3 stringers running down from the deck down to the base and built our steps upon those. We've used offcuts from the floor of western red cedar to form the treads, and all in all we've created an open staircase which kind of welcomes you up to the main entrance of the building itself. So the woodland classroom has come to an end, and I'm off to the next building project. I hope you've enjoyed the DVD and it's inspired you to have a go at roundwood timber framing yourself. Go out there into your local woods and have a look at how the woods are being managed. Search for suitable poles and have a go at building something. My advice is start simple. Have a go at the joints. Get confident in those before you then move on and hopefully build something like a house for yourselves.